Welcome to STAAD.Pro RC Design, and this is basically a dedicated RC design powerful tool integrated with STAAD.Pro. And recently we are using STAAD.Pro V8i SS6, and this video training is for everyone who is related to structural RCC design, maybe columns, beams, and slabs. Those design you can directly do under this RC design tool. And next we'll look into the purpose and other different key important points. So why you need RC design in STAAD.Pro? This is basically a dedicated RC design solution, and that directly can save your time, and that you can utilize, and you can increase your productivity. That is the primary purpose. And how you can select country specific code, that may be American, Indian, and other specific countries, so that you have to make sure while using your design and selecting the particular code. I am Pramit Kumar Senapati, and I basically hold a particular position here in research and development, and primarily dedicated to subject development, and you can say I'm subject matter consultant for whole range of products. And you can follow me through my LinkedIn profile and Facebook as well. So let us start with our agenda here. The key points I'll be discussing about the primary points which we'll be considering during RC design, which is an integrated tool, and then the typical parameters, reinforcement parameters, material properties parameters, and other key uh, particular parameters that you need to consider. That also I'll be discussing. And primary intention is the third step, which is step by step flow. If you miss anything directly, you have to restart the process from scratch. So you have to follow and understand how the whole mechanism of RC design and the step by step flow that you have to understand. So let us understand the key point. The key points are primarily, you can say, the typical bullet points, or maybe the definition, or maybe the process, or maybe your points you do consider during analysis and that you cannot avoid. So before selecting any code or parameters, make sure your model is correct, and also you have to complete your analysis. Let me explain this what I mean. This is the model which we are using for solving your RC design, and my friend is John, which will be taking care of the next session. He will explain the mood about this, how to handle. But primarily here, what I can do is I can show you what you have to consider before proceeding per RC design. So make sure all the parameters like the plate thickness, here we are using a slab, the columns, and the beam typical parameters, those you have assigned, and the material here all are concrete. And also the spec you can use, and you can see here we are using the reduction factor that we have explained in our coming series in brief. So what are those? And also the reduction factor for both beam and columns. And support system, here you can see all the ground supports we have configured correctly. And next, the load definition also, here we have defined, like the dead load, live load, or whatever other loads like seismic or wind load, that you can also configure. And here you can see the wind definition and seismic accordingly. And also if you only have the dead and live load also, you can proceed with this analysis, that is no problem. But make sure you have assigned all the parameters correctly. Then go to analyze and run analysis. Before going to RC design, you have to complete your analysis, and then you can move to RC design. So go to run analysis. So once you see this complete report here, zero errors, zero warning, and your analysis is complete, then only you can move to your RC design. That means you can go to your mode and you can go to your concrete design. Once you click this concrete design, you can enter to your RC design, and this is the primary key points which you do need to consider, and you have to also keep in your bullet point, or you can say your note, that a successful complete of your analysis is required before moving to your RC design program. So what to start then? Our next step is the parameters, and those parameters are related to your beams, maybe columns, maybe slab design, and those are related to your bars, primary bars, secondary bars, stirrups, and shear reinforcement, and your material details and grade of concrete, etc. And those all parameters you have to consider before moving to your complete, the submission of the post processing process, and that is important, and those parameters I'll show you. And if you see this, that typically you have to configure independent parameters related to your bars or material for columns, beams, or slabs. So don't just accept the default. So you have to know or understand your particular case, material grade, and independently you have to consider this before moving to any further step. And let me show you what I mean by these parameters. So when you enter directly to RC design, you have to start by moving to this group or briefs, and what you can do here, that I will show you. But before moving to any particular step, you have to make sure that you have converted all this independent, this member to, you can see independently you can select, but primarily in finite element, this represented single member, and this also, these two typical members are connected as a single connected beam, and that you have to make sure and you have to convert. And how to do that? You can see this particular crusher, it represent your element, means these are independent element. But when you select all this as a group and you directly go to your member, and you can go to form members or auto form member, I will recommend if you go to auto form member, you can see all these are converted to your members. Now if you go to this particular tool, member crusher, and select here, you can see the difference. These are members now. So make sure this you have done before doing any further configurations or work. So this is your first step, that convert those elements to members or finite element, master element. So next you go to your group and briefs. This is most important step where you primarily configure your material conditions and the parameters which you need for your project. You can convert those elements into member by using another method also. If you select all your members here, once you select these members, you can see form members or auto form members. So by clicking this also you can use, or as I have shown before, that also you can see the auto form members. Now let me show you the first step which you have to do. So go to group and briefs and follow sequentially as I am showing you. So if you go to the brief, the first you create the beam brief, then you create your column brief, then you create your slab brief. Don't use any other step like column, beam, or slab. So flow through beam, column, and then slab. So let me select the specific code. I'm selecting here IS456, or maybe you can select SEI 31805 or maybe BS 8110 or maybe a typical your required code. And here I'm giving this as code word beam design brief and go for OK. And here you have to configure your parameters like the general parameter, main reinforcement and shear reinforcement. If you go to the general, here the minimum cover for the top, side and bottom, and here you can update which you need, and the main reinforcing the spacing that you can specify, and you can use your concrete grade here, and the vertical bending and shear design or lateral bending and shear that you can use. Divide the beam into 12 or any typical numbers. If you divide to higher numbers, you can get the intermediate results. And then I'll go to the main reinforcement and minimum size and maximum bar size that I can pick here, and link hanger size and minimum gap, like that the bottom bar criteria that you can select here, like the minimum size, maximum size and link hanger size and gap, and sidebar criteria that you can specify, and the grade, main bars, and then the shear reinforcement and its typical center line of support and column face. That two options you can select. I'm using the center line, and you can use the shear bar criteria and minimum number of legs that you can configure, and shear bar material configuration, and there is the closed type or open type that you can also select. Once you specify this, you can directly go to the new design, but before going to this, make sure you have selected all your beam. And now you can see all my formed members. I can select by single click and hold the control click while adding more number of members. And once I successfully select those members, what I can do is I can go then to new design. Most of the people, they miss it and create, and they get failed message. And this is the brief which I have created before, and I'm adding a design group name. Whatever you feel good, you can add here. And now next step is to go to your concrete member and design. And here you can see these all are members. Directly you can go for the design, and here you can see the successful or failed message. Once you go to design, you can see the envelope selected for this design does not exist or has not been analyzed. So you have to analyze your structure first, as I explained before, and then you can go. And here you can also find the unsupported members in between, so those you can fix here by going to the no support to support mode. All this you have to fix here. So these all methods has been briefly explained, so you can follow in our coming sessions. But this is the primary way how you can do and check the design, and that complete scenario you can check in our coming series. Just like that, what you can do is you can go to your particular design element, and once you design, here you can see the success or failure message for doing your design. And now you can see the particular brief. Once you have finished your beam, you can move to your column, and maybe the column design brief. And once you select and configure your parameters, like the column factors, the bracing is in the G direction or maybe in the Y, and member load cases which you have to consider, that you have to add. Then come to general and configure the bar size and its typical configuration, and the grade of the concrete and its spacing and cover that you can specify. And don't forget to select independent element, and then these members can be considered. And once you select all these member, then you can go for your brief design and assign. So go to the new design, and you assign to your column design, beam design already we have done, and you can give one name, or just I'm keeping it as default. And when you go for the member, concrete member, and design. Here you can find those elements number added, and once you go for design, you can see the design is okay and is highlighted here in the green color. And you can go for the main layout, and you can see the reinforcing details and shear details also. Those all are explained in brief in our coming sessions that you can follow, and results you can get, and schedule also you can see, and you can export to DXF, and you can go, and you can also go for the multi-reverse which format, and DXF is very common and that you can use, and the sheet size here you can configure. But one thing you can see here under Indian standard there is no beam, there is no slabs. So how to do that? So for doing that, either you can go for other code like American and all, and then you check it, and then you revise it and again do that in your own code by hand calculations, or maybe you can use the STAAD.Pro for doing the stress and all calculations, and then you can superimpose those. But it's simple, you can go for any other country code, and here you can see they support slab like ACI 05 I'll recommend, and you can go for slab. But if you select Indian IS, here there is no slab. So I explained the complete step-by-step flow and how to configure and set all these parameters. So one point I would like to highlight here is if you miss any step, you just have to restart your process from scratch. So be careful and pay careful attention and conceive the concept that why we have to start from the beam first, then move to the column, then go for the slab. And don't try your own way, because they have created the program in that way, so you have to understand and follow that particular process, and then you can directly save your time. Thank you.